All right, I think we are live.
All right, let's go.
Okay. So, um, yeah, you're doing file format specification over here, which was this part. We had completed till I think this part.
Yeah,
Yeah.
packaging consideration for streaming and encapsulation.
Mm-hmm.
While ordering with backup service, so there are many interpretation with possible implementation of streaming using multiple.
A file format plugin is not the same as a converter. Okay, it must produce USD scene description. Okay. Usually not create and resolve, create an error resolver, create a schema, create a material binding, use variant, use payloads. And then exam question, look for the phrases like open a proprietary file format directly in USD, reference a non-USD file without pre-converting it, present foreign data as USD on demand. Okay. So we did till here, I guess, LOD in which the first file contains low complexity. Yes, yes, animation with yeah, okay. Packaging consideration. So this is USDZ file format specification layout. We did constraints, we did editability, we did accessibility, packaging considerations for streaming and encapsulation. Okay, it is important to note that the USD runtime has no knowledge or consideration of streaming. It will be responsibility of the client application to manage the scene it is streaming and ensuring not to ask the USD runtime to consume any part of the package that has not yet been delivered. In particular, it must use provided APIs to construct SDF layer directly using offsets into an incompletely downloaded USD package. Bruh.
Yeah, carry on, carry on. I'm just gonna mute myself out.
It must use the provided APIs to construct an SDF layer directly using offsets into an incompletely downloaded USDZ package, rather than trying to point a USD stage directly at the incomplete USDZ package, as the USDZ file format will assume and require that the package it is consuming is complete and intact. For reproducible results, encapsulate using anchored asset paths. Okay. Anchored asset paths to ensure. Okay, we did do this. Yes, we did complete this. Okay. We should. MIME type USDZ is registered with IANA. What the hell? See USDC's IANA registration page. USDC is registered with IANA with the media type name of model and subtype name of VND.USDZ plus zip for fully. Okay. So this is basically, I don't know what this is. But
This is a zip file of of a media type is zip and Z. Oh, it says over the security consideration and where it is used. It's a file format specification HTML, I would say. And what else do we have over here? Additional information, aliases. Interoperability consideration. USDC is designed to allow transfer of. Or it's nothing. It's like the source code of the page that you are trying to open. I would say.
Internet
Defining.
assigned numbers authority registration record for USDC file format. It
In
defines
short,
a
defining.
technical standard for how web servers, browsers, and applications should identify and handle .usdz file across the internet. Key details established on this page include official media type, format purpose. It describes USDZ as an archive format created by Pixar Animation Studios. It is used to package 3D scene data, universal scene description, or USD along with the supporting files like textures into single zip. Bro, stop texting on the fucking or
Oh
connect
yeah,
your earphones.
yeah, I got you. I got you. I'm gonna do a D&D. Yeah, it's done anyways. Okay, yeah, my bad. All right.
Industry usage, it notes that the format is intended for delivering 3D contents with high fidelity across supported platforms. Okay, got it. Toolset. The USDZ file format includes helper APIs for introspecting and extracting data from a package, as well as tailored wrappings for zip API functions for creating and adding files into an package. into an package. Files to an package that satisfies the USDZ layout. What USD file format includes helper APIs, introspecting and extracting data from a package, as well as tailored wrappings of the zip API function. A command line program that accepts either an explicit list of files to package or when provided the asset or ARC ARKit asset options will localize the named USD file, discovering all recursively referenced files, updating the reference to point to their new package relative locations, and create a new USDZ package. The reason for ARKit asset option separate from asset is that USDZ files intended for transmission to iOS devices support a more limited subset of USD functionality. USD zip can also list the contents of a package file and optionally validate the contents as they are being packaged. USDZ files can be unpacked using any zip unzip program, USD-CAD, USD-edit as described above. These utilities will operate on the default layer of USDZ package. Okay, USD checker will validate the contents of the package or any other USD format for USDZ file. Specifically, the USD checker option ARKit will make USD checker enforce the stricter web compliant rules that disallow certain advanced USD features that web browsers do not yet support. Okay. 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 So this is done.
Mm-hmm.
Now we can do maximizing USD performance.
Performance.
Do you want to understand this first? Mm, Okay, best answer is file format plugin versus AI resolver. We have done this. File format plugin versus schema. Define the USD objects. Custom API schemas. File format plugin. Dynamic file formats. Some file format plugins do not simply read static file contents. They can generate layer contents dynamically. OpenUSD calls dynamic file format when an SDF file format generates layer contents dynamically, especially in payload context. Dot prog file may not store every triangle. Instead, the plugin may generate terrain geometry when USD loads it. Okay, this is use of procedural geometry, generated assets, or large data sets. Read the proprietary data directly. Robot CAD, custom file format plugin, USD GeoMesh, XForm data, good for CAD simulation. Okay, reference. Non-native asset support your custom USD like encoding, layer DB, maybe our studio wants to compressed or database backed layer format. Format plugin can expose it as an SDF layer. Generate procedural content. Okay. How to identify it on the exam question? Best answer, create an SDF file format. Open a proprietary reference and own USD file without pre-converting it. Present for okay, okay. Common gotcha. The file format plugin is not the same as a converter. Yes, we know this. Okay. I just want to get this more clarified. Then the next thing that we're gonna do is this maximizing USD performance. Okay. Node is basically clean mental model as USD zip creates or inspects USDZ packages with asset with flag asset. It does dependency discovery localization with an explicit file list. It mostly packages the file you named. Okay. So this is good to understand. Okay. USDZ zip is command line tool for working with USDZ packages. USDZ package is basically USD delivery bundle. The official OpenUSD toolset describes USDZip as a utility for creating USDZ uh, packages from USD composition and the assets they reference. Why it matters? A normal USD asset is often spread across many files, references, okay, texture, that is fine, or studio banner. Other but knowing for delivery, you send only chat.usd client might be missing this. USD zip helps create one package, chat.usd that contains the root file plus dependent assets to main to USD zip. You tell USD zip exactly which file to include. Okay, plain English create chat.usd and put these exact files in it. So usual is you provide chat.usd. Asset localization with asset, this is more important mode for USD pipelines. USD, okay, asset share use. Share.usd as root asset, find all references. Oh, so this is important. I get it. Use share.usd. Use share.usd as a root asset. Find all reference sub-reference dependencies. Copy them into the package. Rewrite path so they point. uh, So point the package. Local copy. The toolset describes asset as taking the resolvable asset path to the root layer of the asset to be isolated and copied into the package. The USDC spec says that asset or AR kit set uses localize the name USD file discovers recursively referenced files. Okay. Hmm. Defx form share prepared references after packaging dot slash. Okay. Dot slash. What localize means? Yes, asset and rail. Packaging for Apple iOS ARKit style consumption. For iOS devices. Oh, so for iOS devices, it is ARKit's asset. The reason ARKit asset exists separately is that USDZ file intended for iOS devices support more limited subset of USD functionality. Okay, asset normal USDZ packaging. ARKit had more restricted USDZ suitable for iOS and AR delivery. ARKit asset. iOS ARKit target ARKit asset. Exact available flux can vary by USD build version, but the conceptual distinction that matters USD zip can package USD zip list share.usd zip can inspect USD. Okay, what files are inside? Check compliance. ARKit ARKit asset. iOS slash ARKit target. Check compliance. Read the package only if the root layer input file compliance. Okay. Unpacking USDZ D chair. Then you might see US unzip chair.usdz there D chair unpack. Normal unzip tools. Okay, what you should use USD tools like USD zip to create valid USDZ packages. Okay, clean notes version. Market consumption. Okay, I think we can move on to maximizing USD performance now. USD zip is clear. All right, maximizing USD performance. How big is this? It's not too big. hmm
All right, yeah. So
Internally,
internally, Pixar relies on USD for low latency access, previews, and introspection of production scale 3D assets
data
throughout our
sets.
3D data sets, my bad, throughout our filmmaking pipeline. We would like to help ensure that USD works as well and with good performance for you as it does for us. Here are a few tips that makes a huge difference. Starting with release 24.11, Pixar is publishing performance metric measured several different assets. You see performance metrics for details. Okay, we can click on that. Let's see how the performance metrics look like.
Performance metrics.
Yeah. What we measure, what environment is used. So to give for a given
Time USD view.
USD,
Time to render first image.
time to shut down Hydra, time to
So
close.
we used one command to measure the time it took for the asset to render on USD view in that
Mm-hmm.
command. So that is like a metric for the performance.
Mm-hmm.
Mac OS 14.3, M2 Ultra, 192 GB
192 GB, holy shit, bro.
RAM.
192 gigs, man.
So Mac OS time to open and close USD view. So standard shader ball. This asset is designed to be a comprehensive test of a broad array of material properties in a single render. Geometry is expressed using USD and materials are defined using Material X. Texture maps are provided by OpenEXR format and encoded using Academy Color Encoding Systems ACES CG color space. In a performance we use MTLX bubblegum material. Note that image shown below is may not exactly match the image generated during performance run. The primary intention is not necessarily to exercise specific renders. The shader wall asset can be downloaded here. I see. So this is a testing asset for
Mm-hmm.
bruh. I can delete that directory?
No, it's your own directory, I guess. No, it
No,
won't allow you to
bro.
delete it. It
Fucking
won't allow you to
USD.
delete the directory because it will give you an error that you do not have enough rights. I would say that
I see.
it is giving you the option, but it won't allow you to delete.
Okay, assets. Okay. So use an allocator optimized for multi-threading. Most of the tips here are about how to construct and structure your USD data files, but this one tip is about software build issue and it can make 2x difference in USD's
in US.
performance. But this one tip is about software build issues. Okay, it requires significant amount of computation building of data structures to load composition of hundreds of thousands of files and efficiently extract the data needed to render a scene. Like many modern systems, USD tries to leverage multi-thread computations and graph building and extensive as possible, and attempting to ensure that the USD code scales as closely to linearly as possibly. As we make more compute cores available to it, Moore's law. Unfortunately, the malloc memory allocators that still ship with some
Are
popular
you sure that's
compilers.
Moore's law? I don't think that is Moore's law.
I think this is Moore's law.
Let's see. No, no, Moore's law is something different.
What is Moore's law? Tell me.
So it's, I don't know the exact definition, but it's not that. It's related to that every 2 years or every 5 years, the compute capacity is gonna get doubled, and the size of transistor is gonna get reduced down by half every certain
Oh,
years.
that
That,
is true. That is true.
yeah,
But that's like something similar to that
and
only.
it's saying linearly. Moore's law is not linear, first of all.
That is true. This is not Moore's law. My bad. But this is some law.
Yeah, I know that's some law, but that's not Moore's law. I just want to tell you that. I don't know
Okay.
what law is it, but it's some law. So just ask ChatGPT, we'll see if it's a law or some bullshit.
No, I think we should not waste time on that. We can move on. I know that
Okay.
is not Moore's law. Yeah, I know. I remember what you said is correct.
Yeah. Unfortunately, the malloc memory allocators
Malloc.
that no, it's malloc. Malloc is the memory allocation. Malloc. That's like C. I don't know what it says. So memory
That's yeah.
allocators that still ship with some popular compilers do not scale well in multi-threaded algorithms that must allocate memory many threads concurrently. Our primary experience is on Linux with GCC's glib compiler, I would say, or glibc, which is based on ptmalloc, neither of which hold up very well under high thread count. At Pixar, we have been successfully and stably using jmalloc, which has the following virtues: outperforms glib consistently in USDC. What is gmalloc? Memory allocator is a general purpose malloc 3 implementation that emphasizes fragmentation, avoidance, and scale concurrency support.
I think I did see this once before as well, somewhere.
First, JMlock first came to use as a free BSD Live C allocator in 2005. Since then, it has found its way into numerous applications that rely on predictable behavior. In 2010, JMlock development effort broadened to including developer support features such as head profiling and extensive monitoring tuning hooks. Modern JMlock releases continues to be integrated back into free BSD, and therefore versatility remains critical. Ongoing development efforts trend towards making JMlock among the best allocators for a broad range of demanding applications and eliminating mitigating weaknesses that have practical repercussions for real world applications. Hmm. I think we
Product
should not
activity.
on everything because it's like
Yeah.
more yeah. Let's ask ChatGPT in 2 lines explain what is JMlock and where is it used in OpenUSD.
I know where it is used. It just said where it is used.
Where? No, it's used in the
It's
compiler.
it's basically a optimized allocator for memory allocator for OpenUSD's performance. Look at this.
No, no, I know, but how is it used? Like how what kind of memory it stores? That's what I'm trying to understand right now.
It has following virtues, bro. Read this. Outperform
Outperforms
glib
Genius
consistently
consistently
for
for
USD stage loading and imaging through Hydra
imaging.
by factor of 2x on a 16 core Intel workstation.
Does an
The,
outstanding job of returning freed memory to the kernel. Oh, I see. In the advanced build configuration document, you can find instructions for how to build USD linked against a third party malloc package such as JMalloc. If you're using a USD in a third party application as an embedded plugin, you can force your application to use different allocators on Linux by using LD preload environment variable. For example, environment LD preload. Okay. Oh, yeah, we are just setting up an environment variable. Okay, and the environment variable name is LD preload, and that
Mhm.
will basically
But I
give
think we
us.
should have that uh, .so or something on our system pre like beforehand.
Oh yeah, that's a compiled binary that we would need. I would have. So you can find instruction how to build USD linked against a third party. Oh, okay, okay. So I think so by default it won't have JMalloc. By default it will have PTMalloc. I'm gonna assume, right? Yeah, by default, and this JMalloc is a third-party M allocation package, not something that you will get with your custom or default packages. I think based on what I have read, that's my understanding till now. Because it says over here in the advanced build configuration document, you can find instructions for how to build USD linked against a third-party package. Sorry, third-party malloc package such as JMalloc.
Mm-hmm.
So if the question comes, what is the default package that is used? That is going to be PTMalloc. And if you want to add third-party plugins or third-party package, we have to update our advanced build configuration and link it using the environment variable LD preload
Mm-hmm.
like this. So LD preload is something that we would have to remember over here.
Mm. I don't think they're gonna ask something like this
You
on the
never know,
exam.
bro. You never know.
Bro, I have given it now once. I know the pattern.
Oh, okay, okay, brother. Okay, okay. We will see in the exam if they ask this shit. Dude, they can
Yeah,
ask
sure.
definitely. If it is in the exam guide, they are definitely gonna ask. I'm just gonna
Mm-hmm.
assume because they. So I think that is a goal for this exam as well, that you should know in and out, like on the lower level as well, how OpenUSD compiles and everything. Because eventually, when we start working on it, this is gone. We are gonna be become. We will be becoming one of the great open source contributor. That's the
Mm.
goal, right? And to understand, like it's like we are trying to understand PyTorch on really lower level, like how does PyTorch writes its neural network libraries or runs its compiler in C++, because PyTorch is all does also have a base for C++ as well, and even
Mm.
Python has a base for C++ as well. It's all about kernel computation and all those shit.
Mm-hmm.
All right. So use binary.usd files for geometry and shading caches. So .usd text file can be a good choice for small files that primarily reference a sublayer and other files together, such as top level asset interface that defines a model, provides its asset info and declares its variant set, and contains a payload arc to the asset contents. But for files that contain more than a few small definitions or override, the binary USDC file format will open faster and consume substantially much less memory while held open. A USD stage keeps open all the layers that participate in a composition. You should not need to exert any extra effort to get this behavior, since creating a new layer or stage with a file name some file.usd by USD will by default create a USDC file. Okay, 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 okay. So wait, what is this? You should not need to exert any extra effort to get this behavior, since creating a new layer or a stage with a file name .usd. Dude, this is something they might ask. By default, when you are trying to create a new file, what will be the default format? And it's gonna be USDC, I guess. Yeah, it's gonna be USDC, not USDA. USDA.
Hmm.
Like I think we did got a question like this, but it was more for translation and conversion thing. But we can also get something like this. That if you
Oh.
write, if you create a file .usd, what will be the default format for it, and it will be USDC.
What? What did you say? What question?
So if you create a file,
Yeah.
some file .usd format,
Yeah.
what will be the format that it will open in
By
when you click on it?
default.
Yes, by
Yeah.
default it will
It will
be
be
USD.
USD. Yeah, brother. We we did the same thing in the
Yeah.
fucking 2 days ago. We did the same thing, and I said the same thing. Uh, a mother of me. Welcome, welcome. Okay, let's move on.
All right.
Why .usdc is better for heavy layers? The file contains a lot of authored data. Text
Text
becomes
becomes
inefficient.
slow.
Thousands or millions more. Okay. Shows the same using but more efficiently. Yeah, okay, whatever. As much as your pipeline allows, you should also prefer binary USD files over Alembic caches. For performance, Alembic is a groundbreaking and outstanding interchange format for geometry caches and can perform very well in an Alembic-based pipeline. However, while USD is committed to supporting Alembic as an input to composed USD scenes, it cannot perform as well as the native USD files for two reasons. In order to provide lockless data access in highly multi-threaded client. In order to provide lockless data access, okay. In highly multi-threaded client, one must configure an Alembic Ogawa archive to open file redundantly as many times as you have threads. Each open file retains as a file descriptor, and file descriptors on Unix systems are finite resources. Finite resource, especially in applications that still use the select system call. We commonly construct USD scenes that reference thousands to 10,000s of files, which would result in hundreds or of thousands of required file descriptors to make Ogawa competitive with USDC for multi-threaded data access. Okay, where USDC by default needs to retain no file descriptors for the files to keep it open. Our Alembic file format plugin does not explicitly configure the archives it opens, which results in single file descriptor being consumed. but all threads contending to read data from it. Okay, although the Alembic and USD schemas and data types are mostly equivalent, they require translation at the C++ data structure level. So there will always be an extra level of copying translation required when serving Alembic backed data to USD. You should not need to replace all your Alembic exporters with USD exporters to achieve this, because a USD file format plugin system makes it very easy to convert between supported file formats. To convert a file from Alembic to USD, one needs only use USD CAT. Okay. So USD CAT like that with whatever USD file you have, and then just convert it to ABC Alembic.
Mm-hmm.
Okay, I think I get it. Each open file retains file. Okay. In order to one must configure to open the file redundantly as many times as you have threads. Each open file retains the file descriptor, and the file descriptors on Unix systems are finite source resource, especially in applications that still use the select system call. We commonly construct USD scenes that reference thousands to 10,000 of files, which would result in hundreds of thousands of required file descriptors to make a Java competitive. What are file descriptors?
What are file descriptors? I think the metadata they would be called. I think I'm gonna assume there will be metadata, like the descriptors. They would be the metadata of the file. And can you also check your GitHub notification? I have sent you the invite for the iOS app that I've been working on. Yeah. I'll go over there. Yeah, accept.
Okay.
So yeah, just clone it, and Cloud Code will ask you to install Xcode, and
Mm-hmm.
you can also run it as an emulator, or you can also load it into your iOS app. There might be some bugs, so if you find more bugs, just
Yeah.
create an issue, or you can also work on the bugs by yourself as well.
Okay. I will.
Mm.
3-day weekend, brother. I will work on this.
Yeah.
Probably.
And we are using custom LLM as well. Like we are using a Llama 3 billion, and it works pretty fine.
Mm-hmm.
I would need your help as an AI software engineer to optimize that part as well. Like it's
Sure.
completely vibe coded. Like the app is fully vibe coded. I don't know what the fuck Swift is. Frankly speaking,
Mm-hmm.
you can just go with the flow as well if you want to.
Kaltura video embeds. What? What is Kaltura?
Where is Kaltura? I don't know, bro. I'm telling you, I don't know shit. Like it's everything related to Swift programming, I would guess. And Swift programming is like based on C++, C sharp. Syntax pretty much matches C sharp for the Swift programming.
Mm-hmm. I see. Yeah, I will take a look.
Tiger is caught in camera. Tiger, you are on the stream now. Tiger has went for using laundry,
I see. In
like
2 days?
formal. Yeah, bro. 2 days. Too much clothes. Too much clothes.
A file descriptor is a low level operating system handle that represents An open file or file-like resource in simple terms. The file name is how you find a file. The file name is how you find a file. The file descriptor is the handle your program uses after the file is already open. What it is when a program opens a file, the operating system gives it a small identifier. So file name is chair.usdz, program opens it, open chair.usdz, file operating system returns file descriptor 3. Then the program does not repeatedly say read from this internally, it says read from the file descriptor 3. Okay. And what was this? In order to provide lockless data and multi-threaded on as many times as you have threads. Okay. Archive to open the file redundantly as many times as you
Done, brother.
have threads.
Oh, coin time.
Each opened file retains a file descriptor, and file descriptors on Unix systems are finite sources. Finite resource, especially in applications that still use a select system call. We commonly construct USD scene would result in okay.
What is Ogawa? What is Ogawa competitive?
To make Ogawa competitive with, I think that is the Alembic file descriptor or Alembic.
Oh,
So 1 second, I'll ask that as well. Oh, competitive with USDC for multi-threaded data access. Okay, where USDC by default needs to retain no file descriptors. For the file, it keeps open. Okay. Oh, not explicitly configured archive, it opens. Okay. Ah, I see. Home key is the file descriptor. Okay. Path on disk. You come because you use efficient access of the fucking. Okay, okay. Mm-hmm. Explain the Alembic Ogawa multi-threaded data access. Okay, okay. Package assets with payloads. When dealing with large scenes, important pipeline can be, yeah, this we already know. These tasks can therefore be accomplished with more quickly if the URL does not populate. Those asset reference asset composition are called payload. That is essentially referred reference. It is allows us to structure Cs so that we can open stage and loaded, meaning that USD will populate the stage only up to payload arc of an on effective way to make sure this is to publish each of your model assets such as file that referenced into assemblies and short is very light box, lightweight description of models interface example asset info variant sets, rest bounding box, and a payload arc to a separate file that pulls in the complete geometric and shading description of the asset when a scene constructed from references to assets built this way is open and loaded. You get a summary view of the scene that will contain its model hierarchy, which is sufficient for some entire tasks, and if not provided all the information necessary to load just the model instances required for the task. Large scene can take seconds or minutes to open. Um, but typically the model hierarchy view can be opened in under a second or a small number of seconds. Okay. The USD distribution includes an example Python script that demonstrates one simple kind of asset packaging using payloads. Okay. USD distribution includes an example Python that demonstrates one simple kind of okay. What makes USD scene heavy and expensive? It's common knowledge that more geometry you have in the scene, the more complex shading you have, the more expensive it will be to render, and that is true regardless of how you feed the data into the renderer. While we do not have mathematical formula for how to structure data in USD for minimal latency and lowest memory footprint in getting data to render, we do have some guidelines that we try to keep in mind. Prefer create files as described above. Putting in big data and .usda files increase latency to opening a stage and memory footprint. Monitor layer count. The cost and weight of opening a scene scales with the number of files that must be opened. Offers much of the workflow power of USD comes from its ability to maintain references to assets, and this caution is not meant to inspire anyone to flatten out their sets or environment into single file. Rather, it encourages careful consideration of common published asset structure. In our own experience, it is too easy to solve asset authoring organization problem by throwing new layers at it. And the number of published layers per asset can quickly rise from 3 or 4 to 10 or more, and those increases multiply by every uniquely referenced asset in the scene. By the time the asset is ready to be published, typical workflow issues that benefited from many layers are no longer relevant. So, when possible, try to collapse layers as part of a publishing step. Currently, the only provided flattening tools are USD CAD Flatten and USD Stitch, each of which are limited in their handling of composition arc. We hope to provide more flattening options in the future. You can count and examine the number of layers that are required to produce the current view of the stage using USD stage get used layers. Okay. So this is important. You can count and examine the number of layers that are required to produce the current view of the stage using USD stage get
Good.
used layers.
Correct.
Minimize
What do you mean?
prim.
It's like we can also unload layers out if you do not want, like maybe for example, for the current view, there might be some layers that exist but are not loaded into the current view. Is that possible?
What?
So if you load our current view, right, and it is saying that you can count and examine number of layers that are required to produce a current view,
Yeah.
right? So is it possible that there are some layers that are not loaded into the current view, but when we try to use get used layers, it will give us only the layers that are active, not the layers, not the
I think
total
no,
count.
I think it's gonna give you all the layers that are used to
So that means the layers that are
compose.
active for the current view, right?
Not only active, I think also the inactive layers, because
No, 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 no,
it
no.
contains,
No,
bro,
see, you see.
because
Yeah, go ahead.
it contains payloads. So much of the payloads might not be loaded yet. So it means that those layers will also be included in those used layers.
Wait, let me ask. Yeah, use get used layers function. Does it loads all the layers or only active layers?
Only active layers, bro. It will only load active layers. How will it load
Active layers,
inactive?
right? Okay,
Yeah.
okay, okay. Yeah.
But
I
see
just want to make.
what is it saying?
Okay, so returns the only layers that are actively participating in current composed stage.
Yeah,
Not every
exactly.
layer that exists on disk or that has ever been referenced. Oh, okay, okay. So if the layer is also referenced, but it is not actively participating, then it
Mm-hmm.
won't be loaded. So it's fine if the layer is referenced in one of the active layer. But if it is not getting
Mm-hmm.
used, then it won't be loaded into the get used layers. Like so, get used layer won't count it
Mm-hmm.
even if the layer is referenced. Because you remember in variants, we can also have nested variants where we can have multiple references assigned to multiple variants. So if you put one of the variants active, then other variants won't be loaded. That means the other references that are mentioned in the file or in a layer won't be loaded as well. So it won't count those layers, I'm going to assume.
Mm-hmm. Okay. Minimize prim count. The cost and weight of opening scenes also scales the ultimate number of prims populated on the resultant USD stage, but much less so with the number of properties contained in the scene. This is due to the fact that prims can introduce new composition blocks into the scene. Therefore, each prim must be uniquely indexed and the results cached for later property evaluation. This leads to the following guidelines. Leverage transformable G-prims. Take advantage of the fact that geometric primitives in USD are transformable. Do not create an parent X form for a mesh for the sole purpose of transforming the mesh, since you can transform the mesh directly using exformable properties. The Alembic file format plugins collapses X form plus shape combinations into a single transformable G-prim in USD geom. Leveraging the feature of the USD geom schemas typically cuts the prim count of scenes by Leveraging this feature of the USD geom schemas typically cuts the prim count of scenes by 40 to 50% depending on the scenes branching structure. Where primitive parameters in USD are transformable. Do not create an parent X form for a mesh for the sole purpose of transforming the mesh, since you can transform the mesh directly using its X formable properties. Oh, the Alembic file format collapses Xform plus shape combinations into single transformable G-prim and USD geom. I see. Leverage transformable G-prims. So G-prims can directly be transformable without putting them under a parent X form.
I see.
Use instancing at higher granularities. Even if your renderer is able to instance an individual G-prim, there is compelling advantages to expressing instancing at higher granularity and simply letting your renderer process USD prototype redundantly for each instance to get the instanceable gprim. While gprim level is instancing is expressible in USD, it provides zero prim count reduction and actually adds somewhat to the cost of opening the stage, since you have introduced at least one instancing composition arc onto each leaf prim. The overhead should not be substantial enough to discourage you from instancing at the fine grain, but rather encourage you to add another level of instancing on top of it, such as the asset level. Okay, prefer property namespace. So what is you even if your runner is able to individual comparing advantage to expressing using that higher granularity and simply letting your internet process the USD prototype randomly for each instance to get this is with gprim. While gprim level instancing is expressible while gprim level instancing is expressible in USD, it provides zero prim count reduction and actually adds somewhat to the cost of opening. While gprim level instancing is expressible in USD, it provides the zero prim count reduction and actually adds somewhat to the cost of opening a stage, since you have introduced at least one instancing composition arc into onto each leaf gprim. Should not be substantial and use instantly higher granularities. What the fuck? Higher granularities?
Like more flexibility.
The quality or condition of the level of scale, the scale or level of detail present in a set of data or other phenomenon. The scale or level of data, higher granularity. So the
Like
higher
more lower
detail,
level, like more it provides you more flexibility with options. It provides you more power over changing anything. So it,
higher details, bro.
yeah.
Granularities
No,
mean details.
but using instancing at higher granularities, that means in depth, like you are going to each and every detail of an object. Let's say you have this ball, so you're gonna go to the texture and every freaking thing of everything that exists on this ball.
Hmm. Prefer property namespace for organization. Properties in USD can be organized into namespaces similarly to the compound properties. In Alembic property, namespaces are simply reserved separator character dot with the API for creating the enumerating properties by multiple levels of namespacing. User properties, primevars, and other property schemas leverage property namespaces effectively. Okay, such as asset level. Hmm. Okay. So let's take a look at this part, and then we should be done with maximizing USD performance, and then we should be left with API docs for encoding, stage up access.
Can you open API docs? How big is it? Like, can we take a look at it? If it's too big, or we can do it tomorrow if you want to continue.
I think it's pretty big. No, not too big.
No, dude, it's yeah. We can also complete this in today's stream probably, and then yeah.
Mm-hmm.
Oh, yeah. Let's go back to where we at. Okay.
Okay, the statement means Alembic Ogawa can read well in parallel only if each thread gets its own separate open file handle, but that explodes the number of file descriptors in large USD scenes. USDC avoids that problem because native USD create files are designed for efficient multi-threaded access without needing one retained file descriptor per thread file. This is from OpenUSD's performance guidance. USD supports Alembic input, but native binary USD is preferred for large composed scenes because Alembic backed data has both file access contention and C++ data translation overhead. What it is, Alembic is a geometric cache interchange format. It is commonly used to store baked animation data. Baked animation data? What the fuck is baked?
Reloaded.
Converting dynamic real-time calculations into flat static keyframes.
Every single frame. Oh, I think it's similar to value resolution. I would say converting dynamic real-time calculations into flat static keyframes on every single frame.
I see.
Okay.
1 second. MCP versus API. Oh yeah. Everywhere, bro. Okay, USDV file form. We already did this. Okay. Yeah. Okay. So USD can reference Alembic files through Alembic file format plugin. Plain English USD scene references an Alembic cache. USD Alembic file format plugin presents that Alembic data as USD. Scene description. Ogawa is Alembic's newer binary storage backend. Okay, Ogawa is Alembic's new binary storage backend. It replaced, competed with older HD F5 style Alembic storage in many pipelines because it is simpler and better and not fast reads. For your notes, Alembic scene cache format Ogawa is equal to one binary backend storage layout used by Alembic. So when the code says Alembic Ogawa archive, it means alembic.abc file stored using Ogawa backend. Why multi-threaded access matters? Modern USD clients are highly multi-threaded. For example, Hydra USD imaging validation tools or pipeline tools many have many threads asking for data at the same time. Read mesh point a file, point from file A, read normals from file A. Okay, so visual USD stage asset 001.abc. Okay, multiple threads want data at the same time. The ideal situation is thread 1 reads, thread 2 reads, thread 3 reads, thread 4 reads, no one blocks anyone else. That is what lockless data access means. Okay, what lockless data access means? Lock is a synchronization mechanism. A lock is a synchronization mechanism if multiple threads share one file handle.
The system may need a lock so they do not corrupt shared read state.
Okay, shared file handle thread 1, 2, 3, one Alembic archive, one file descriptor problem. Only one thread may safely access the certain shared state at a time. Thread contents. So the access becomes thread 1, 2, 3, 3, 2, 3, wait, reads, waits, reads, waits. That is contention. Or to avoid this, Alembic Ogawa can be configured so every thread opens its own copy of archive. Thread 1, 2, 3, 4 Alembic archive opens 1, 2, 3, 4 file descriptor. Now each thread has an independent read access. This is what the code means. Open the file redundantly as many times as you have threads. Oh, it does not mean copying the file handles. It means opening the same file multiple times, producing multiple OS level file handles. What file descriptors have to do with it? Every time a fucking program opens a file, the operating system gives a file descriptor. Okay, so you have a Limbic file, 16 worker threads, and you want fully lockless Okawa access. You may need roughly 16 open file descriptors for that one file. Now scale that you to a USD scene. Okay, why this becomes USD scale problem? USD scene often references many files. The code says USD scenes commonly reference thousands to tens of thousands of files. OpenUSD's performance guide makes this exact point when comparing Alembic backed scenes with native USDC scenes. 10,000 Alembic files is 16 threads. To make Ogawa competitive to lockless multithread, 10,000 files into 16 open per file, 160,000 file descriptors. Visual, okay. Huge file descriptor demand. That is the problem. File descriptors are finite on Unix-like systems. Each processes has each process has limits on how many it can keep open. The exact limit depends on the OS and produce or process configuration. So the trade-off is few file descriptors, less OS resource usage, but threads contended. Many file descriptors better parallel reads but may exceed OS limits. Why select is mentioned. The code says, especially in an application that still uses select system call. Select is an older Unix API for monitoring file descriptors. It historically has practical limits and scaling issues when dealing with large descriptor numbers. You do not need to go deep for USD certification. For notes, right? Select may makes very large numbers of file descriptors problematic, especially problematic in some applications. Hundreds of thousands of file descriptors is not practical assumption for many applications. Why USDC is different? USDC is USD's binary crate format. This code says USDC by default retain no file descriptor for files it keeps open. So USDC crate can keep layer data accessible efficiently without holding an OS file descriptor open for every file in the same way. So USDC is better suited for large compose USD stages where many threads need to read data concurrently. Visual comparison. Okay. Ogawa high parallelism, USDC efficient native access pattern. Okay, conclusion is Alembic is bad. Better conclusion is Alembic is used for interchange cache format. USDC is usually better as a native format for large composed scenes. Okay, I get the idea now. One Alembic file, one opened archive, one file descriptor, many threads share it, thread contention. So thread 1234, one USD ABC file, plugin archive opens, one file descriptor. Low file descriptor usage, but more contention. It does not open one archive per thread, so the plugin avoids file descriptor pressure, but the cost is reduced multi-thread. The second performance issues data translation, port performance. Bruh. Alembic Ogawa can avoid thread logs by opening the same archive once per thread, but every open consumes a file descriptor in large USD scenes with thousands of reference files that can require impractical number of descriptors. So USD's Alembic plugin typically opens each archive once, causing threads to contend. Native USDC is preferred for large USD scenes because it is USD native, more efficient for multi-threaded access, and avoids Alembic to USD data translation. Ogawa needs many opens for lockless reads. USDC is already built for USD scale parallel thread reads. Parallel reads. Okay, I get it. We can move on to encoding stage up
Mhm.
axis. So even if USD geom camera objects in a scene are encoded with a transformation that assumes y-axis is up, that cannot always imply that geometry contained in the scene was modeled with y-axis pointing up, since some modeling applications assume z is up, and others allow you to configure whether y or z is up. More. Oh. That cannot always imply that the geometry contained in the scene was modeled at y-axis pointing up. Okay. USD Geom API function. TF token USD Geom get stage up axis, fetch it, and return stage up axis. API bool. Okay, USD Geom API bool. Okay, USD Geom set stage up axis, set stage up axis to axis, which must be one of USD Geom tokens Y or USD Geom tokens Z. USD Geom API TF token. Okay. USD Geom get fallback up axis. Okay. What the fuck does this shit mean?
API token, bool, TF token, stage up access, and where a linear. Wait, what is fallback GAT for fallback up access? TF token is token dot x. No, wait, we have stage dot up dot along with the access. So we can define.
Oh, oof. I don't know what you need from me. Can I get a memory? Mm-mm. Read this, bro. Detailed description.
Even if all the user geom camera objects in a scene are encoded with a transformation that assumes the y-axis is up, that cannot always imply that geometry contained in the scene was modeled with y-axis pointing up, since some modeling application assume z is up and others allow you to configure whether z or y is up rather than impose one axis or the other on all USGM scenes, which would require either transposing point coordinates into and out of some applications or making assumptions about where a 90-degree rotation that has been applied effectively. That is minus 90-degree rotation, not plus. Mysteriously swapping the roles of Y and Z, we allow each stage to carry in its root layer a description of the up axis for all geometry contained in the stage and require application to consult if they wish to create new cameras to view the scene in its intended orientation. Now that because you can only make a stage level declaration of up axis, it must hold true for all reference geometry and assets. A consciousness set environment construction tool could examine the up axis of referenced asset as they are referenced and apply a corrective rotation on the referencing prim as it is being added to the scene. When reference up axis differs from sets, we provide free functions for setting USD stage up axis, retrieving USD geom stage up axis. Wait, what the fuck? Set stage? We provide free functions for setting, okay, for both of them. And declaring a site fallback up axis, that is USD geom get fallback up axis that can be configured with the plugin. See, bro, plugin info.json is definitely a global file that is used for every other fallback value configuration
Mm-hmm.
for any OpenUSD architecture that we will be using, even for asset resolvers. So using plugin.info.json, you can set up your custom AR resolvers, your fallback plugin access as well
Mm-hmm.
over here now. So the see the individual methods for detail. The stage up axis is encoded as stage metadata up axis whose legal values are Y and Z as represented by USD GM tokens Y and USD. Oh, these are the tokens. Oh, yes, yes. USD GM tokens Y and USD token GM tokens Z. So this is what it is talking about in the above. Like if you go up, yeah. So TF token. So this is what the tokens are, Z and X axis. We have been using these. We have seen a lot of usage in our
Mm-hmm.
learn OpenUSD toolkit as well, that we have to define stage up axis dot token and then the token sets to X or Y depending upon what's up, like what is the up for our stage,
Mm-hmm.
right? And yeah, let's go down. Okay, so the stage up axis is encoded as a stage metadata up axis whose legal values are Y and Z as represented by USD geom tokens Y and USD geom tokens Z. Of course, constructing a correct camera view of a scene depends not only on the up axis but also on the handedness of the coordinate system. So like OpenGL, the fallback of USD geom prim get orientation attribute, and USD geom stipulates a right-handed coordinate system. Therefore, when viewing a USD stage with a Y up axis, when the stage Z axis will be pointing out of the screen, and viewing a USD stage with the Z up axis and stage Y axis will be pointing into the screen.
Mm.
So
Creating schema function documentation.
what does the function? Okay, yeah. So we have to define the up axis in this manner. So USD geometrics. So this could be I'm gonna say like analyzing the code or troubleshooting and debugging what is the issue in in this code.
Mm.
How are you going to use or set up with the fallback value? So this is how we will use USD geometrics, and we have to define a axis as a key, and the value will be z over here for the TF token.
Hmm.
That will be used by USD GM get fallback up access.
Mm-hmm.
Okay, and if this is the important thing, if unauthored, we will return the value provided by USD GM fallback up access. Exporters, however, are strongly encouraged to always set the up access for every USD file they create. Returns one of the USD GM tokens Y and USD GM token Z unless there was an error, in which case returns an empty TF token. Oh, so might be a scenario where it can also return an empty TF token if there is an error.
Mm-hmm.
Hmm. And I think the by default handness of the coordinate system is right-handed coordinate system. This was a question, I guess, that I saw in my quiz, that what is the default orientation. So it's going to be right-handed coordinate always.
Mm. I don't remember that question.
But I had that question, so yeah, I did wrong. Okay, I think we can focus on the ChatGPT one. Three functions are about stage up level access. They tell or set whether a user stage considers Y or Z to be up. They do not rotate your geometry automatically. They are metadata that applications and pipeline use to interpret the scene consistently. So the NVIDIA study guide lists encoding stage of access as a relevant topic for data exchange and pipeline development. So this is a certificate relevant, it says over here. So what it is, in a 3D different application use different up direction. So Y is upward, and if you scroll down, like in the first 3D orientation, it is showing that Y is up, and in some worlds Z is up. So usually supports, oh, it's rotated, oh wait, oh, it's inverse, oh, I see. So it's always gonna be, so X is gonna be like this, Y,
Mm-hmm.
and what the fuck, yeah, like this, what the fuck, I have to remember inverse Z. Okay, or it's gonna be inverse. So USD supports stage level metadata call up axis, that is gonna be Y or Z. Let's go down.
Wait, 1 second. These three functions are about stage level maxes metadata. They tell or set whether the USB stage considers Y or Z to be up. They do not rotate your geometry automatically. They are metadata and applications and pipeline tools used to interpret the scene consistently. The NVIDIA study guide lists encoding stage up axis as a relevant topic. Okay. It's in 3D, different applications use different up directions. Y upward, Z upward, USD supports stage level metadata called up axis equal to Y or up axis equal to Z. This tells consumer in the stage this axis should be treated as vertical or up. So the three functions are USD geom stage up axis, USD geom set stage up axis, and USD geom fallback up axis.
Axis.
So this one reads the stages up axis, authors the stages up axis, and returns the side default fallback if the stage does not author one. So USD Geom stage up access stage, USD Geom API ETF token, USD Geom setup stage up access const, USD stage weak PTR and stage. This fetches the stage's current up access, plainly asks the stage, are you Y up or Z up? Example USD Geom tokens. Y or USD Geom tokens Z. Okay. In Python, we do USD Geom dot stage up, get stage up access stage. Important blah blah blah. Read the stage of access metadata, print something like Y or Z. Okay. This sets the stages up access. This access must be one of the USD geom tokens. Okay, Y or Z. So USD geom stage up access, stage, comma, access, and okay, access must be one of USD geom tokens. Y or okay. This stage uses Z as vertical direction. Okay, USD Geom get fallback up axis, USD Geom API TF token, USD Geom get fallback up axis. This returns site level fallback axis. If a stage does not explicitly say Y up or Z up, USD still needs some default answer. So the fallback in is the default USD installation site configuration. Visual the stage has authored up axis. Yes. Use authored up axis. No. Use fallback up axis. So this returns like a default fallback. token commonly Y depending on USD side. So it is commonly Y. The default is
Yeah.
commonly Y. Depending on USD side configuration, what is TF token here? TF token is the USD sufficient interned string type. Instead of passing arbitrary strings like Z, USD prefers predefined tokens. USD geom.tokens.z. Tokens are faster, safer, and avoid repeated string allocation. So USD geom.set stage up access stage USD geom tokens.z is preferred over thinking of it as a random string. Why it matters? App access affects the scene interpretation across tools. For example, Maya style scene often via CAD engineering. Some DCC scenes often Z up. Okay, if the up axis is wrong, the scene may appear sideways or incorrectly oriented in other applications. Correct interpretation is Z up. Application knows Z vertical, so it stands upright. Incorrect interpretation. Z ups asset. Application assumes Y is vertical. Asset may appear rotated, lying down. Important. Gotcha. Okay, got it. Okay. Okay.
All right. So I think we have completed our USD stage encoding as well. So I
Mm-hmm.
think we can probably focus on other reference links tomorrow, and we
Mm-hmm.
can go ahead and end the stream.
Yeah, let me see what this traversing a stage is. Okay, it's not too big. Converting between layer formats. This is something that we've already done using USD cat. I think it's not too big either. Okay, stage traversal is something we have already done. Hmm. Extend him. What USD boundable class reference? Get boundable. Extend. Okay, so this is big. USD boundable class reference is big. That we need to do. It is a very big topic. Why extends and not bounds? I think. Okay. Okay. I'll end the stream now.
All right, guys. Adios. We're gonna carry on tomorrow, and the streak continues. 70. How many days? One or 70?
70, 70.